All right. So a series basically, right? A series occurs when we right? So when we sum, right? When we sum all the terms in a sequence, we end up with a series, right? Right? So an example of a series is if you were to sum everything in a sequence from R going from 1 to n, that will be a sequence, right? So a sequence might be the first term, second term, all the way until we did to the end term, right? And we did an example of this we did an AP and GP using this summation, right? Everybody okay with that? Right? You might remember the AP and GP. So for example, if I gave you an AP and I asked you to sum the terms, we had something like this, right? Right? This was for AP to sum all the terms, and then we had for GP, right? A by 1 minus R to the n over 1 minus R. Right? There's some quick things you need to remember about series, right? Right? And we spend some time on the AP and GP, I think, and so on. Right? You all remember the rules for series? No? Like if I give you the sum, huh? Yeah. Well, so, what's the rule here? Right? You could pull the key on the outside. Right? What's the rule here? What's the rule here? Right? If I give you something like this, you can split it up, right? So you'll get the summation of R going from 1 to n of a to the R plus and minus the summation of R going from 1 to the n of e to the R. Okay? There's some rules for you to remember. What would happen if you sum? What would happen if you sum R going from 1 to n of a constant? What will that be? The constant by n. Okay? Remember this rule? Yeah. You make it think of that rule there from us. I know that's something that I want to add. Huh? N minus 1. So what do I write here and here? What do I write here and here to make this summation equal to this summation? Huh? What do I write here and here? Huh? All right, so let me make it, let me make the question easier. If you had P, here's what? P plus 1. Right? So if I split up a summation, right? Let's say it at 10 terms, right? Let's say it at 10 terms. 1, 2, 3, 7, 8, 9, 10. Let's say you have 10 terms. Let me write order. 4, 5, 6. Let's say we have 10 terms, right? And we want to split it up. So the summation of R going from 1 to 10 is the same as, I can break it up here, the summation of R going from 1 to 5 plus the summation of the sixth term. So that will be 6 to 10. Okay? So I just kind of showing you how I'm breaking it up. So if I stop at the P term, I start back at the P plus 1 term. Okay? What would happen if I started back at P term instead of P plus 1? Huh? I'll be adding P twice, so at the minus of P for it to be equal to that, right? Because I know, right? We're going to take a picture. Yeah. Gosh, I'll just send you a picture. All right, so there are just some rules that you need to remember about summation, right? No, they'll give you, I think they'll give you this now. No, let me wait again. I think this will give you one of them. You don't get it? This will give it. Yeah, no, they might give it these, but I think this will give you one of these. According to which book, let's see get. Right, and well, we would have proved these already in form in unit 1, right? How to get this system in PMI. Right? How you work this out here then? How you work this out? Which formula will you use? 4 and 5. So, right, but before you do it, you can probably do this, right? Yeah, we can probably expand it out. Right? And then you get R squared plus the summation of 2R. That's okay. What you can do next? So you could use the summation R going from 1 to 10 of R squared plus take out the 2 you say, right? Right? And then how you get the R squared? Huh? Right? So use the formula for R and R squared. Come over again. What's that? If you could use 5. Factorial. Right? Yeah. Square it now. That's what I do. Now. I won't give you the same thing. You can see. Try pass some more, you got? Oh, yeah, Sean. Alright, so what's your thought? Huh? Right, what we got here? R squared is which one? N is what? 10, actually, by 2 by 10 plus 1 plus 2 by a half by 10 by 10 plus 1. How much is that? 495. Yeah. Yeah. Okay. Right. So I was just using the rules. Right. I'm just show you that quick. Oh yeah. Comment there. Right. Use the rules now and we'll get out from out. Try this here. Right, 5 to 15. Try that quick. Take your time, right? The problem here is that we have 5 to 15, right? So can I use the rules for 5? So I remember 5 cube, sorry. But can I know I can't use the rule, right? I can only use the rule of what? If it starts with 1. So we have to find a way now to do that here. Huh? Put 1 in the calculator. And you'll get 0. You gotta work it out and show them how you get. So you have to find a way to use 1. You have to find a way to bring in 1 here, right? I'm not getting in there. Darren in the wrong class. You'll figure it out. Right, yeah. Any ideas? Sean and Vanaya. Any ideas? Come on, for your phone, please. How are we doing this? Separated. What separated variables and integrate? Something else we had to do. Remember the rule I showed you here? Where 1 to n, you can split it up? Yeah, you have to use that rule. That was rule what? 4 or 5? 6? That's rule 4. So you have to figure out how to use rule 4, right? To get this. Try it quick. I've given you a step here. Right? I'm putting in 5 to 15 here. Must have to figure it out. So we can figure out what will go here and here. I basically give you the answer. Right, Emily? I basically give you the answer there. Right? So figure out what going here and here. And then make this the subject and the formula. After you make something. Try it quick. Right, so what do we put here? What do we put here? Here's what? Cabby 5, 1 to 4. And here's what? 1 to what? 1 to the whole thing, right? So 1 to 15 is 1 to 4 plus 5 to 15, correct? And then I can make this the subject. So I'll end up with of 2r cube is this minus this. So the r going from 1 to 15, you can put all the 2 if you want. R cube. Come. Right? Plug in the formula for r cube. R cube, you can factor the whole 2 if you want. And then tell me what you got. Right? Do you all follow what I did? Right? I cannot use the formulas unless I have one underneath here. Right? So now I can go to r cube and use the formula. N is 15, use the formula, N is 4. I could not have used it here because the denominator, because the underneath value limit here is 5. Okay? It has to be 1. Right, Shane? So I was able to do it by using the fourth rule I gave you. Yeah? Plug it in now, Tamoyega.
AX plus B equal to A plus B.
One time to the same. Yeah. Right, I'm gonna put the diary on this wrong class here, nah? I'll put the timetable to the crash course of this week, right? Today, I'm going to put today, I'm going to put right? No, I'm gonna go on the diary. Huh? Okay, and then one time, so they can get it, and I'll put the Google sheet on the URL to fill it out next week, right? Nope. Yeah.
I'm full scale.
How much will I get? How much? Huh? No way usually. In fact, I like that number right. Right? What's the formula for R cube? 1/4 by? Huh? By? Right? And then I put that in the calculator. Right? To do the same thing here. 1/4. I'll put the 2 on the outside, right? So it don't matter, right? I'll put the 2 all the way on the outside. So it'll be 1/4 by 5 squared. Sorry. 4 squared and 5. How much you got? 28,000. That's it? Okay, nice. So sometimes you can simplify like this. Sometimes you have to find a different way to simplify it, right? Sometimes we actually going to have to focus on this and simplify it up, right? That technique that I'm going to show you now is something called method of differences, okay? But in order to do method of differences, you need to learn, you need to remember your partial fraction. Online, are you okay with us? Like, yes. Yes, boy. Figure out that. That is the yes center. Alright, next method, head up method of differences. Method of differences. Right, method of differences can be used. Method of differences can be used to simplify summations. So remember, if this doesn't work, you use method of differences, right? It is tough here, but sometimes if you can't see R squared and R cubed and R, then you have to use the next one. No, you come back to that, but like if you see like fractions and then that's when you're working. So method of differences can be used to simplify summations. First up, once the function can be written, once the function can be written, once the function can be written in the following form, once the function can be written in the following form, watch it for a minute again, right? So if I give you this, and you could find a way to write the function as two other functions, the difference of two other functions, then we could use this technique I'm talking about, right? So you see like this, we can't really write this in terms of two functions and minus it, right? But if I could take g of x and write it like this, we could simplify it out and apply this what I'm telling you all now, right? So in the form summation of g of x equal to this, then we can simplify then underneath this, right? Then we can simplify, the terms, then we can simplify the terms by canceling off, no. By canceling off all the terms except the smallest and the largest. By canceling off all the terms except the smallest and the largest, which is normally the first and the last, which is normally the first term and the last term, which is normally the first term and the last term. Yeah, listening. Right, g of x written into two terms, h of f of x minus h of x. Right, just do me one favor. Look back, you can look back, right? Ignore the summation. Use partial fractions and break this up, please. Yeah, boy. I repeated lean. Oh, that's a quadratic.
Sorry.
Right? Use partial fractions here. Giving it 2 minutes. 2 minutes. Use partial fractions and simplify it.
Right now, I tried to buy.
You can do it, but you can do it. Hey.
Right, and how.
Right, so I just focusing on this one on R by R plus one, Shivish. What we have here? Two what? Huh? Never learn that. Shivish never learned that. So these are two what? Two linear, right? And if it's a linear denominator in numerators, right? This is linear, so is that. Right? What is it now, Emily? What is it now? Multiply by what? R by R plus one, right? So you multiply by that, that'll cancel. So you'll get 1 is equal to A by R plus 1 by B by R. Expand and compare the coefficients. Is there any R term here? So it means that A plus B is 0. Is there a constant here? Yes, A is 1. So if A is 1, then B is what? Minus 1.
Yeah.
Right? So watch here. Watch this part here that happens. Right? Here's where all the excitement comes in here. Right? So watch this here, right? So what do we end up with? We end up with the summation of R going from 1 to N. Online? Are okay? Online? Are okay with us? Navi, following? Right? So watch this here. This here could be written as this by using A is 1 and B is minus 1. So I could write it like this. Open with brackets. A is 1 over R minus 1 over R plus 1. That's okay? Yeah, Tivish? So I took this expression and I broke it up in terms of two terms minus in the middle. Right? So this is the difference here. That's okay? So once you could write this like this, we can apply method of differences. All right? I know you're copying it down, so I'll give you a minute. Reach here. Right? Reach up till here, and I'm going to write some terms here, right? I'm going to write the first term, second term, third term, and the last three terms. Fitted here.
So we are right. We're trying to catch up because we didn't teach the answer, right? We will. We'll talk about it, Sally. We do. We do it. But I think it's US police.
Alright, what's here? Somebody write themselves? So I want to write out some terms here for you, and I want to show you what will happen. When you apply method and differences, what's supposed to happen again, Wyatt? All the terms except the first and the last, right? Or the biggest and the smallest. Ready? So what you see? What's the first term? The first term is R is 1, so I put 1 in here. 1 over 1 minus 1 over 2. That's the first term, correct? Second term is what? Part 2, right? So that's 1 over 2 minus 1 over 3. Third term, 1 over 3 minus 1 over 4. Plus, I'm skipping out the rest, and I'm going down to the third to last term. Okay, I'm going down to the last term. Second to last, third to last, second to last, last. What's the last term? 1 over n minus 1 over. What's the term before that? N minus 1, right? So that'll be 1 over n minus 1 minus 1 over n. Correct? And the one before that is what? N minus 2 minus n minus 1. Right? So look at what happening here, right? If you watch what happening here, this minus a half will cancel here. This minus 3/4 will cancel, minus 2/3, minus 1/2 will cancel here. Right? That's okay? This quarter will cancel with whatever next to it, right?
Yeah.
This 1 over n minus 1 will cancel here. This 1 over n will cancel here. This will cancel with whatever before it. So everything canceling off except the largest and the smallest value. So what we end up with. That's okay. So if n is 5, I can put 1 over 5 plus 1. Are you okay with that? If n is infinity, 1 over infinity. Which is, well, the whole thing will be 1. That's okay. So method of differences is you have to identify. Sometimes the question will say, well, find this and then find this, and you'll recognize there's a minus in the middle. Sometimes you have to figure out and you have to apply partial fraction. That's okay, Ariane? Right? And in method of differences, you don't want to write so much. I just write it to show you. You could just write first 2 and last 2 and cancel. Okay? And you end up with the biggest and the largest. Right? It's not always the first, sometimes the biggest term is here, according to how they write it. Sometimes the biggest term is here. There's one example I remember it was here. Right? But it's always 2 terms remaining. Copy it out. Are you ready? Next one.
Give me up.
Huh?
So long give me up.
About 9.
Minutes? Yeah.
Try that please. 2/2r plus 1. 2r minus 1. Right. Anybody remember from GPs how to show if a series convergence? Think about it, right? Why are working this out? Plus series, right?
Wait, what? Let's see.
Right. Try that again, please. The good thing. Like you don't need no more. You sound like you're going on. It's a water. It's a water. Should we do it thing like the same thing from before? Huh? Hurry up. Right, while you're working, think of how to show if a series is convergent, right? And I want you to remember the GP example.
No.
No, not lunch. Yeah, the whole thing, simplify the whole thing.
Freeze road.
I just asking all this. What I realize. Right, so take your time and
That's right before taste of happiness. Like more now. I thought like no, yeah. So that's ended over right there. It's not already. Yeah, you're going down. Whenever it's traffic, that goes straight, right before taste of happiness. You know what taste of happiness is? Right. Just go there.
select the button and put it out.
Yeah, come here. It's not like past taste of happiness. It's right.
It's quite simple. Right, so when you reach here, right, it's a linear, right? So you will end up with 2 is equal to A by 2R minus 1 plus B by 2R plus 1. So you'll get 2 is equal to 2R minus A plus 2BR plus B. Right, so we will end up with 2A plus 2B is 0, and you'll end up with minus A plus B. Minus A plus B is 2. A is 1 and
B is minus 1.
oh, B is minus 1 and
A is 1. No, A is minus 1 and B is 1. It depends on what you. Yeah, it depends on your fit.
like if you have it like this, 2R. What is above 2R plus 1?
A.
A. So
Minus 1.
A is minus 1 and B is
1.
1.
I can do this anyway.
All right, nice. Right, so we'll end up with the summation of R going from 1 to n. Oh yeah. So B is the what A is the minus, right? So I am just flipping mines around. So I'll get the minus here. Okay. So I'll put in B. B is 1 over 2R minus 1 minus 1 over 2R plus 1. Right? And we're going to expand it out. First term, sorry, well, expand this out. First term is 1 over 1. Second term is 1 over 3 plus 1 over 3. Right? And I'm putting any more, and I'm putting the last term, right? The last term will be 1 over 2n minus 1 minus 1 over 2n plus 1, right? One line I just squeeze in the last term here, sorry. Right? The last term is 1 over 2n minus 1 minus 1 over 2n plus 1. Of course, everything will cancel except the first and the last. So we will get 1 minus 1 over 2 to the n plus 1. So if I ask for the sum of R going from 1 to infinity, what will that be? What will that be? If I ask for the sum going from 1 to infinity, it means that n is infinity, right? So that's 1 minus 1 over infinity, which is 1. Arian, you okay with that? So Arian asked a question a little while ago, right? How can I know if a series is convergent? Huh? Now, that's not general case. What do you think? why it is that AP did not have a sum to infinity, but a GP had a sum to infinity? Huh? Yeah. That's a different one. Why it is that AP?
Because conversion don't go to infinity.
All right, you're close. You're close. What's that? Okay, so what would be sum to infinity for AP? For AP, it will be infinity, right? Right, so there's no value. But if you find sum to infinity with GP between -1 and 1, what you'll get? You'll get value, right? So what it's saying, it says that if we were to find sum to infinity like this here is technically sum to infinity, you know. You realize that? You sum from 1 to infinity. So if when you sum from 1 to infinity, you get enough value, it means that this series is convergent. That's okay? Just like a GP. Are you okay with that? Are you okay with that?
Yeah.
So if you find sum to infinity here and you end up with a value, it will not always be 1. But once you get a value, it means that that series is convergent. It's similar thing. Yeah. But there are 2 ways you can write. I want you to see this one. Okay? So that's the way you can prove a series is convergent. Right? So you all recognize the use of method of differences. Image. We could use method of differences to check for convergence. Okay, I'll give you a note on that now. That one on one?
Yeah.
That one will give you 0 for everything. Love for this evaluation.
Hey, that is not a building full story, so full story, you know that. In Australia, you only have like a big deal there. Yes. Yeah. I can't listen to that. And if he breaks up, if he was what, I agree with it. I don't see that again. Because he just gonna look at it. Yeah. Yeah, no, the higher ups. Yeah. So he's the real thing.
All right. Convergence of a series. Let's take a small note. Take a small note. Convergence of a series. For a series to be convergent, for a series to be convergent, for a series to be convergent as n approaches infinity, as n approaches infinity, as n approaches infinity, the series should approach some value L. The series should approach some value L. That is, sum to infinity should exist. That is, sum to infinity should exist. That is, sum to infinity should exist. Full stop. Note that a GP is convergent. Note that a GP is convergent when R is between what? -1 and 1. Note that a GP is convergent when R is between -1 and 1. Note that the second thing. Note that 1 was that. Note that 2. Second thing to know that. Second thing to know that, Nikash. Method of differences can be used. Method of differences can be used to determine if a series is convergent or not. Right? Determine if convergent here. Check these two out and see if any convergent. Check and see if any convergent. Right? This is S to the N, right? So you can check as N approaches infinity, what S to the N is. Right? So as N approaches infinity, but again, you can do that mentally. Right? You're getting 1/6 by infinity, by infinity, by infinity, which is infinity. So therefore, divergent, right? That's okay? Yeah?
Yes.
1/6 infinity. But I'll make it convergent on it. Forget 1/6. But I'll be done with them. Guy number 2. Check and see if it's convergent.
Not convergence. It's convergence.
Yeah, that's it, both of them are there.
It's convergent. Agree? What am I saying?
So, why?
It's
Huh? Why I get conversion? So we go with that.
Yeah, I get after it.
Right? So the limit as n approaches infinity of s to the n, this is s to the n. That would be 3/4 minus a half 1 over infinity plus 1 over infinity. Right? What's 1 over infinity again, Shivish? Shivish? That'll be 0, right? So the final answer will be 3/4. So since the limit exists, it exists, therefore it's convergent. Yeah. Very good. Very, very good.
Oh my goodness. Yeah.
All right, question. Take a look at the one board there. Right? On the board, I give you a different sign. Right? We have to figure out now if that's convergent or not. So we are in the next rule. Anybody remember something about the GP between -1 and 1? What we can say about the GP, let's make up one, right? So suppose I give you a GP like this. A is 2 and R is a half. Okay, let's list out these three terms, sir. 2 then, and the last value is what? The last value is 1 over infinity, which is 0, right? So what you recognize about the sequence, Emily? What you recognize about the sequence here? There's a GP, right? This was a GP. What you recognize about the sequence? No, not the series, the sequence. What you recognize about the sequence? It approaches 0, right? So, can we use something like this? The limit as n approaches infinity of the sequence equal to 0. This implies series is convergent. Yeah. So if we could show that the sequence tends to 0, then the series is convergent. Because we know that this is convergent, right? We know, Vinaya, that once we have a GP between -1 and 1, it's convergent. Are you okay with that? So this is a second rule that you can add, right? There's a second rule that you can add. If the sequence tends to 0, it's convergent. Can you help me simplify this one? What you use here, Trey? Two methods to simplify limits. Two methods are what? Factorize first, and then divide by the highest power. Can you factorize here? Now, so you had right. So divide by the highest power and see if the sequence tends to 0. If that happens, then this series is convergent. Are you understand that?
Yeah.
Ariane? You understand that? So you're checking to see if the sequence tends to 0, right? If this happens, convergent. Write it down and see what I'm looking at. Right, so I'm coming back and do number 3 right down here, right? So I'm checking the limit as n approaches infinity of this. Right, we can't factorize, so divide by the highest power and time over again.
Yes, right now, it's really slow. Alright, it's good.
Everybody's just like.
Oh yeah, divide the limit, time over again.
Because differentiate.
Right, we find it two answers.
It's one. Is that the one that makes sense?
Oh yeah, 75,000. Much again. Right, Paulia, please write the last line. So what does that mean? So 2n on n all over 2n on n plus 3 over n. The ends cancel here, so you'll get 2 over 2 plus 3 over n. Right? When you plug in n is infinity, you'll get 2 over 2 plus 0, so you'll get 1. What does that mean? Therefore it is divergent. Huh? Well, if it's not both of them, yeah, a chance it could be that. That would have formed. But yeah, it could be. It has formed a period.
Just keep it.
You okay with that? Come here. So you have to remember the two rules to check the convergence, right? Check the sequence if it's 0, or check the series given you the value. And this level, you just get very good.
Check what? Check series. What does it? Check series. Check series of value. That's
All right, so it's important that you understand the difference between both of them, right? All right, so that is your series. Technically, that's it for series, right? Hopefully, I'm not doing any